What if Amazon, Google Cloud, or other centralized companies decide to withdraw their support for cryptocurrencies that heavily rely on these companies' computing and storage services? In such a situation, all the blockchain services would collapse like a house of cards, leaving the crypto world in pure chaos. This means all of your investments, capital, and everything can be doomed in a blink of an eye. And that's where Internet Computer Blockchain, ICP for short, steps in. It's created to solve this reliance on centralized companies by aiming to power decentralized applications from end to end. The idea of the world computer would become one of the most ambitious, complex, yet efficient technologies, which was proposed by the Ethereum team back in 2014. It consists of a combination of features that allows everyone to create apps, store data, and access global resources through a decentralized architecture. It essentially aims for a global, open source, fair, and equitable system. Although Ethereum decided to ditch this idea due to the lack of transaction and data storage capacity in the networks. Nevertheless, Dominic Williams, inspired by Ethereum, decided to pursue this vision, and of course he had faith in ICP. Their vision was to create a blockchain that would be fast, efficient, and scalable just like the world computer. And then the Internet Computer was born, being the first decentralized computer ever that runs at the speed of the web. Scalability of a blockchain is one of the most critical factors and the biggest challenge while creating a network. Because bigger scalability means better performance, which will not be affected as the network grows and adopts new features from the newly evolving technology. For example, Ethereum and Bitcoin are long plagued by scalability issues, which they're trying to solve with additional layers. But sadly, this often costs them decentralization. However, Internet Computer achieves unlimited scalability via chain key cryptography. Transactions are validated by using decentralized signatures instead of having to compute the entire blockchain since Genesis. To generate that signature, nodes cooperate through an interactive protocol that uses their shares of a private key to generate a single public key. Since the IC has a single public key, transactions can be verified by any device, including smartwatches. So nodes do not need to store terabytes of a chain to validate transactions, which make Internet Computer more efficient and scalable than other blockchains. Now, you might be wondering, how about the pace? Well, speed has some measurable parameters that can help us here. Let's take a look at Ethereum. Its average block time is 14 seconds, which gives us the amount of time needed to create the next block. This number becomes exactly 0.045 seconds for Internet Computer. How great is that? But the actual speed is indicated by transaction finality, since it's the time that it takes the end user to make a transaction from one account to another. So it's basically your wait time. In comparison, Ethereum requires 5 minutes for this, which sounds reasonable until you hear Internet Computer takes care of it in 2 seconds at a web speed. And in terms of security, do you remember when I mentioned in the beginning that cryptos often rely on off-chain solutions? Which is okay when increasing the efficiency of the platforms and applications. But using centralized solutions that are not on the blockchain network is not entirely secure. For example, supposedly you want to interact with a decentralized application on the Ethereum network. In that case, you need to use an external wallet like MetaMask, which is not always as convenient as it could be to do so. There can always be problems with such external wallets where users become unable to access their funds. The most significant example is when the MetaMask network went down and didn't allow participants to use Ethereum's blockchain. On Internet Computer, though, everything can be done on chains. This way, decentralized apps can have the front end and back end powered by smart contracts which run on the network nodes. So, on top of being able to use traditional wallets like Plug Wallet, you can use the Internet Identity, which can be understood as an on-chain wallet that uses biometrics for login and can be restored with a seed phrase. This allows you to interact with dApps securely and without any browser extension. Now the question is, why does the Internet Computer achieve all the better than others? How does it work? So Internet Computer uses software that is an upgraded version of smart contracts, called a canister. Canisters are computational units where data and code coexist. You can think of it as improved smart contracts. Canisters are little server containers that can run WebAssembly code and store around 4 GB in RAM. And unlike traditional smart contracts, they can perform many things along with building a software service that can be scalable, hence the infinite scaling the internet computer has. Canisters are hosted and served by the internet computer, so they're impossible to tamper with. These functions are what makes internet computers so fast, as they say, at web speed. The consensus mechanism on top of the chain key cryptography allows internet computer to be ahead of other blockchains, driving the platform's performance and allowing it to scale to an unlimited capacity. As you might have already known, Bitcoin uses proof-of-work consensus, which relies on validating transactions via mining and computation power. Proof-of-stake is what Solana uses. This mechanism happens when validators stake their coins to confirm transactions. Internet computer, however, uses something called threshold relay, which is a heavily optimized yet complex version of the proof-of-stake model. Another key feature of the internet computer is the ability to integrate with other blockchains without bridges. In a simple way, canisters can have addresses on networks such as Ethereum and Bitcoin. What this does is bring the powerful internet computer canisters, which are similar to smart contracts, to offer computation for these other chains. The final transactions then happen in these original networks without the need for bridges. This is a special breakthrough, considering how many hacks there have been on bridges. Now let's talk about the incentivization and rewards, which Internet Computer's ICP tokens covers all, and it has two main uses. The first is that ICP tokens can be locked inside the network nervous system, something like an on-chain DAO, to create neurons. These neurons provide votes on governance proposals and earn voting rewards like additional ICP tokens, pretty much like staking. Also, it's important to mention that the longer you keep your neurons, the more voting power and rewards you get. Plus, you shouldn't dissolve your neurons earlier than 6 months to participate in voting. And if you choose to stake, return rates are in favor, ranging from 15.4% per year for 6-month staking to 28.9% per year for 8-year staking. However, the rates can change depending on the voting and the number of ICPs being staked. And second, ICPs can also be converted into cycles to power computation done by canisters, which is a unique feature. So even though the internet computer is not widely known like Ethereum or Bitcoin, it surely offers whole evolutionary technologies which seem to possess the power to make true decentralization happen in every aspect of our lives, ranging from website and game hosting to social media, Bitcoin integration, multimedia storage, and more. But what do you think? Does ICP seem like a worthy project to you? Share your thoughts in the comments below. And if you liked the video, make sure to hit the like and subscribe buttons. Thank you for watching, and until next time.